Hello everyone, welcome to my YouTube channel. Today I'm starting a new series on data modeling. So let's get started. So in this today's video, we will learn about what is dimensional modeling, what dimensional model does, like why we need dimensional model, then what is star schema and OLAP cube. Okay. So before starting, we all know that for any organization, their data is the most important asset, right? And the organization use their data for mainly two purposes. Okay. The first one is operational system, and the second one is data warehouse or business intelligence. Okay. What does operational system means? It means where we put the data. Where we put the data. Sorry. And the data warehouse or business intelligence means where we get the data out. From where we get the data out. Okay. Let's consider one example for Amazon. Okay. Suppose what operational system does, like it will contain the information like in daily basis. Okay, it will contain information in daily basis, like in one day, like suppose today, in today how many number of sales are there, how many new customers are registered, okay, how many user queries are there. These all information are stored for operational system. Okay. Also, the operational system doesn't contain any history. Okay. Suppose there are some customer, we can consider example like for customer ID 3, the name is Ram and their email address is ram123 at the rate gmail.com. Okay. Suppose the customer Ram update their email address to rm123 at the rate gmail.com. Okay. Then what operational system does? It will delete this data and update with the current data. That is, here will come 3 Ram and the current email address, that is rm123 at the rate gmail.com. Okay. The operational system only update the data that is the most current state. Okay, this one is the current state, so this will contain only this value, not the previous one, what is the Ram's email address. Okay. Whereas what does the data warehouse or BI system does? It will maintain the history. Okay, because from now we can analyze the data warehouse, like analyze the data. Okay, like it will see in a day, it like operational system where consider with daily basis, while the data warehouse, it will consider your data, it can be a week ago. Okay, it can be a month ago, it can be a year ago. Okay. So for the analysis, the data warehouse have to maintain the history, right? So this will the data warehouse work with historical data also. Okay, you can say that historical data. While the data warehouse or business intelligence system, what does, it will count the like it will check the total number of orders. Okay, the total number of orders, and for suppose it will consider like what is the total number of orders for this week and what the previous week. Okay, and it will check why the number of orders are decreasing or increasing, if there is any promotional activities are going on, or is there any festive seasons are going on, what is the reason behind the number of increase or decrease on the orders. Okay, similarly it will check the number of new customers register. Okay, new customer registered for this week and for the previous week, or this month or previous month. Similarly it will check why these are the numbers are increasing or decreasing. Okay, basically data warehouse and business intelligence, what does it will check the data and analyze the data and consider why this the number is increasing or decreasing. Okay, so from this we can say that the data warehouse or business intelligence deals with the uh, deals with tons of data, like it will historical data, you can say that historical data. Okay, because to analyze something it will some analyze something like it, we have to compare with current data on the previous data. Like the for previous data we have to maintain the history, as we know that the operational system doesn't maintain history, it will update with the current state of the data, while the data warehouse maintain the history because it have to analyze the data. Okay, so as we maintain history, it will evaluate from that, it will evaluate it will evaluate the performance of an organization. Okay, the data warehouse evaluate the performance of an organization. So now we can say that the operational system deals with business run. Okay, business run, how to run the business, whereas the data warehouse is deals with to analyze the business growth. Okay, to analyze the business growth. Okay, so yeah, from here now we can say that data is usually only for two purposes. One is the operational system, another is the data warehouse or business intelligence system. Okay, the operational system contain the information like when the order is placed, new users sign up. Okay, and it deals with one transaction at a time. Okay, like as we say that it doesn't maintain history, like it will doesn't maintain history, it will just update it with the new current state of the data. Okay, it update with the most current state. Similarly for data warehouse, it will analyze the data like how many total order are placed, like it will compare the data with current state and the previous state. Okay, like how many new customers are signed up, like and find out the reason why. Okay, like why the numbers are increasing or decreasing, like why the numbers of order are increased or decreased, why the new customer sign up are increased or decreased. Okay, suppose like it compares with the previous data and check why the numbers are increased or decreased. It never deals with one transaction at a time, and it maintains history to evaluate organization performance over time. Okay, so as our topic is the data warehouse and data modeling, so we will more focus on data warehouse and BI system. Okay, not in the operational system. Okay, so why we need data warehouse? Before we knowing what is data warehouse or data modeling, we will learn that why we will use data modeling. Okay, data modeling, why we will use data modeling, like what is the purpose of data modeling. Okay, So the main purpose of data modeling is it will address our two requirement. The data modeling basically address our two requirement. Okay, the first one is it deliver data that is understandable to business user. Like it will understandable data, we can say that. Okay, understandable data. And the second one is it will deliver faster query performance. It will faster query. Okay, what does this means? Okay, it basically addresses our two requirement. The first one is deliver data that is understandable to business user, and the second one is deliver faster query performance. What is the meaning of deliver data that is understandable data to business user? Means it will convert our complex data into clear and insightful data. Okay, here there are some example. Okay, suppose we have an example like the reason why is the product and sales amount. Okay, here we can say that there are some reason like north, south, east. Okay, and the date and the product item and the sales amount. Okay, if we check here, there are some values are null in the reason column. Okay, and also there are some null in the product column also. Okay, this is the data as we receive uh, from the upstream. Okay, we can say that from upstream. As we receive this data, we cannot send this the exact data to the downstream also. Okay, like or to the, we cannot present this data to the business also. Okay, because there are some null values are present also here and here also, because there are some no values in reason like null, like there the reason values would be north, east, west, south. Okay, there are no null in the reason, like there is no name null like reason. Okay, and there is some product is also which is null, but they have some sales amount. This cannot be possible, right? Is there any product name is null? No, right? So we have to clear this data. Okay, so how do we clear this data? First of all, there can be two method. Okay, the first one is we can say that the first one is we just remove the invalid records, like we'll remove this row and we will this row. Okay, and the second one can be your uh, fixing the invalid records. Like if this is null, then we will replace with some north, south or east, but this is not validated, right? how can we uh, how can we like update with some random values? Okay, so the best choice, like the most of the time we will use like to remove the invalid records. Once we remove this invalid record, what will this look like? If we remove this, suppose contact, like if we remove this one and this one. Okay, once we remove this data, this is the data first we have finalized the data. Okay, now from this data we can consider like the reason why is which product is most sale, and the which reason is the lowest sale, and the which product is in which date it sells most. All those information, like all these queries we can find like in the fraction of time. Okay, if there is some null values, then there may be some data inconsistency which is not feasible, right? This is what means that understandable to business user. It now the business can understand it quickly, like yes, there is some reason like north, south, east and west, and the products are this and this, and this, according to that the sales amount is like this and this. Okay, but if there is some null values here, then what the business will they what business will understand, like there is some null reason. Maybe this is a new reason or whatever. The business will confuse, right? This is not feasible data, so we cannot send this data to the business, right? First we receive data from upstream, we will like clear the data and send the data to downstream. Okay, similarly, if we talk about the deliver faster query performance, what is this means? You can say that the faster query performance, it means like we have to design a system in such a way that we can search or apply some filters in a fraction of time. Like if we search something, then we can find this in a millisecond of time. This not take much of 5 to 10 minutes, right? So we have to sit there and to apply filters. Like if we apply some filters here, like it is the for north reason, what is the product that is sells most, then it will be give the reason like then it will be given the result in the milliseconds of time, right? Or if suppose like if someone makes some power bi report, okay, power bi report, and give to a manager for presenting, right? Then whenever the manager will open that report, then that report should open in within a second, right? It should not open within the 5 to 10 minutes, so it will take to like more time. Okay, and if we apply some filters also in that power bi report, then the result will be in showing the quick time. Okay, right? Done. Like suppose manager representing to the market, then the manager will not wait for like yeah, wait, and the filter is applying. This should not be the case, right? So we have to design some data warehouse or data modeling, right, in such a way that this will query the first, this will give the result, give the query, and give the apply the filter and give us the result within the fraction of time, right? So data warehouse resolve our two requirement. Okay, sorry, the data modeling resolve our two requirement, that is the deliver query that is understandable to business user, and the second one is deliver faster query performance. Okay, so from here we can say that the modeling data modeling is a technique. Okay, it is a technique for making database simple. Okay, of course, if someone like query something or apply filter something, like from where we get the data, from database, right? From database or from data warehouse we get the data. So we have to model something like that is making the database simple, so that we can apply the complex filter, complex logic, complex query, so that it can be worked in a quick time. Okay, so yeah, so to design a data model, we have to start from simple as possible, because if we start from simple, then at the end it can be a like simple or moderate. Okay, but if we start with complex, like there is so much joins and there is uh, uh, so much of joins and all those things, then at the end it can be a more complex. Okay, to which we have, but we make this now, and if we looking at after some time or some days, then we also get confused like what happening in this or that. Okay, So we have to create a data model as simple as possible. Okay, so let's note like, yeah, you can say that the dimensional model is a designing technique for data warehouse and BI system. Okay, it optimizes the user query performance and data analysis, right? Okay, so by the time we will learn that what is dimensional modeling and why we use the dimensional model. Okay, now we will learn that what is star schema. So star schema, we can talk like that, when a dimensional model is implemented on a relational database system, like relational database system, your like your MySQL, Oracle, or PostgreSQL, then we will call that star schema. Okay, why we will call that star schema? Because of their structure only. Okay, because it form like a star like structure, we can say that it form a star like structure, so that we will consider it as a star schema. So what this contain? This will contain like, suppose we can say that here counts the terms as the fact table and dimensional table. Okay, so here at the center there is a fact table. Okay, and around it there are some supporting tables. Okay, these are called dimensional table. These are dimensional table. Okay, the fact table will contain like information like some numeric value it will contain. Okay, and the dimensional table will contain some descriptive information. Okay, we can consider it like, yeah, this one is the example. Okay, this is the fact table. Okay, this is the sales fact table, and these all are a dimensional table. Okay, we can say that the fact table, what is contained? The store ID, the product ID, date, customer ID, the promo ID. Okay, from where these data are get from the supporting tables, like from the dimensional table. Okay, we can say that the store id is comes from the store dimensional table, right? And the product id is comes from the product dimensional table. Okay, and the promo id also come from the promo dimensional table. Okay, so from this join we can say that if someone is to find like, from which store the most amount of sales are present, like some most sales are there in the which store id, then we can find that from the fact table only, right? If there is no fact table, then we have to join multiple joins, like from store id, and then from product dimensional table, which which store supply more sales. Okay, all these things we will have to get. So to easily query something, or to easily apply filter something, we have to use the data modeling, right? And the data modeling will comes from, one is the star schema. Okay, star schema, where we can say that the fact and dimensional table will make. Okay, we'll learn more about the fact and dimensional table later in the later videos. For now we can say that just consider like a star schema is made from the one fact table, and there can be a multiple supporting tables which are called as the dimensional table. Okay, so if there is a complex query, like if we have to find like in which we have to find the in which date, the in which store the which product is sells the most amount of the product, and which customer buys that, then we have to join multiple tables like the date dimensional, store dimensional, product dimensional, and the customer dimensional. Okay, we have to like join more tables, and the query can be complex. Okay, if we store all the more information in the fact table, then the query will be simple. Like we can from here, from the only fact table, we will get that the what is the store id, in which date, which customer, and which product it sells most. All these things we can get with a simple query from the fact table, right? So we can see that here the fact table contain only the numeric values. Okay, but the dimensional table contain the descriptive table, descriptive information. Okay, descriptive information like what is the customer id, what is the customer name, and what is the customer phone number. Here we can also say that what is the customer address. Okay, from here also we can say that what is the promo, what is the promo id, what is the promotion name, what is the promotion description. Like it will be the promotion is apply on any festive season or any non-festive season. Okay, now let's take about OLAP cube. Okay, so when the dimensional model is represented with multi-dimensional database, then we will call that OLAP cube. What is in case of star schema, it will represented with relational database system. But in OLAP cube, if there is a multi-dimensional database, then we will call that OLAP cube, right? So think of it like instead of just one table, the data is stored in a cube-like structure. Okay, so like how to visualize the cube. So let's understand with one example, right? Suppose you own a supermarket, can consider like GeoMart. Okay, so each day we will record some data like what is the date information, we can the store location, and the product information, right, and the sales amount, right? So each day we record this information, like in which day the store location, which product sells, what is the amount of that product. Okay, so if after 1 year, suppose after 1 year, if the business owner will ask the question like which product sold the most, like like which product sells the most, or which city performed the best, or how much sales, or how much sales on the January month. Okay, then if we store these informations in a single table, then this will take much time to query, right? If we store in like some cubical structure, then the query filtering will be faster, right? So in OLAP cube, the data is organized in multiple dimensional like 3D like structure. Okay, so we can say that there is a cube. Okay, there is a cube, and here each side is represented something different. Suppose here this side, the front side is represent your product, then this side is suppose represent your date, and suppose the upper side is represent your product. Sorry, this is not your product. Suppose it's your store location, we can say that. Okay, store location, and this side is represent your sales. Okay, so from now we can, if the business will ask like question what is the sales over time, or what is the sales by product, what is the sales over time, like what is the sales on January month, then we can rotate this cube and find the answers, right? This is the sales and this is the date. We can say that in which date, like from date we can find out the month, right? From which month which sale, what in which month the sales is most, right? Or the sales by product also we can get. Sales by product also we will get from this side, right? From this side, and from this side we will get the what is the product, right? So by rotating this cube we can find the answer easily, we can say that. Okay, so when we load the data into the cube, like in the OLAP cube, the system store it in a specific format. Okay, when we load the data into OLAP cube, it will apply some like pre-calculated value, some pre-calculated values, or apply some indexes, right? Indexes, uh, so that it will make your query faster. Okay, like if we search something, then it will give the result in within a fraction of second. Okay, like while ingesting data into the cube, it will apply some pre-calculated values or some indexes, like and summarize the data in advance. Okay, so this is the advantage of cube, we can say that, for faster query performance. But the main disadvantages, we can say that main disadvantages, we can say that loading and preparing data, right? While loading the data and the preparing data to load into the cube, it will take much time, because we have to apply some pre-calculated value, like pre-calculated value, because it will uh, takes within like it will take some minute of time, or it will take some seconds, second of time for search the query. So that we have to ingest the data by pre-calculated value, right? And preparing the data so that it will take less time, right? So the only disadvantages is, like, while loading the data, while loading data, it will take some extra effort. Okay, so otherwise the OLAP cube give result us in within a fraction of time. Okay, this is the advantages of OLAP cube. And yeah, that's it for now. And in next video we will learn about what is fact table and dimensional table. We'll learn about fact and dimensional table. Okay, so thanks for watching. Please like and subscribe my channel. Thank you.